So in this video, we are going to talk about the chi-square test of independence. So the symbol for a chi-square is this up here. It is the cursive capital X with the 2 in the superscript. With a chi-square test of independence, all of your data is nominal. So you have no real measures of anything other than just frequencies of groups appearing in your data. So both variables are nominal, and it's kind of like a correlation where you're just looking to see, is there a relationship? So really the purpose here, this is telling us if there is a relationship between two nominal variables. Neither variable is considered an independent variable, and neither one is considered a dependent variable. They're just two variables. So the way that we are going to test if there's a relationship between these two categorical variables is we are going to look at the frequencies of how they occur together. Is there a pattern in the frequencies such that one category of one variable is occurring more frequently with a certain category of the other variable, and vice versa? So we're just looking at frequencies in data, what was going on, and then what frequencies would we have seen if there was no association. So what this is called from a textbook perspective, we're looking at the observed frequencies in the data. So our observed frequencies and our expected frequencies. And those expected frequencies, that is what we would see if there was no relationship. We're going to compare those two, what was observed and what would be expected. If we're seeing similar results, then we're going to say that there's no relationship. But if the observed frequencies are really different from the expected frequencies, then we're going to say there is a significant difference. And essentially, we are getting a p-value, and that p-value, we're just comparing it to alpha. It's going to tell us if there's a significant relationship or not. So really, the process of doing a chi-square test of independence, you get a chi-square test statistic and you get a p-value. But in Excel, there's a function that kind of calculates the chi-square test statistic behind the scenes and then just gives you the p-value. So for efficiency purposes, we're just going to go with that for this class. Our assumption here, you do need to have at least 5 occurrences of each category in your data set. So if you don't have that much, you need to gather more data. A few example questions. At one company that I was working at when I was in practice, my manager came to me and said, we are concerned that men are more likely to develop career roadmaps than women. Career roadmaps, it's a road to success. It's a guide that you build with your manager, talking about what career goals you want to build over the next 5, 10, 20 years. It can be very motivating and give you a lot of direction in your career. And we're really concerned that men are more likely to do this. So I did a chi-square test of independence to see, is there an association between, gender and whether or not you have a career roadmap. Another way that this could be, another business question where this test could come into use, is there a relationship between attending a training program and receiving a promotion? So those are both, kind of yes or no outcomes. Training, did you attend a training program? Yes or no. Did you receive a promotion? Yes or no. That's both categorical data. So this test would be useful to answer that question. And is there a relationship between customer gender and vehicle preference? Again, 2 nominal variables here. So this would be an appropriate test. Okay, so how do we conduct a chi-square test of independence? So I'm going to show you all of this in Excel. Note that I have snips here of what I'm doing, the results, and I have steps written out on the slides for what you're going to do. So let's go through it in Excel. So we are going to do a test to see if different functions were more likely to train their managers. Is there a relationship between function and manager training? So going back to my data set, let me delete all this from the ANOVA video. The first thing you're going to do is create a quick pivot table. So insert pivot table and click OK. You're going to pull one of your variables into rows and one into columns. So I'm pulling function into rows and manager training into columns. I'm then taking either variable and putting it into values. Okay, so this is what we have here. You might want to filter out the NA just to keep things simple. These are our observed frequencies here. So this is what we observed in the data set. Then I'm going to put our expected frequencies here. Now, to get the expected frequencies, we're going to follow this formula that's shown on the slides. Row total times column total divided by your total sample size. What you're going to do, you're going to take these row totals times these column totals divided by the grand total for each category combination. The easiest way to do this is to copy where you see row labels down to that bottom total. Copy that and paste it here. And we are going to clear out these center numbers, and you're going to follow that formula, that equation. So I'm going to do equals row total asterisk times column total divided by grand total. You're going to follow that for every blank cell that you see in the center. So row total times column total divided by grand total. Row total times column total divided by grand total. And I'm going to do the same thing here. Okay, so once I have my expected frequencies, I'm going to do the chi-square test function, which is going to give me a p-value telling me if these counts, these frequencies, are significantly different from these. So the function is equals chi test. And then in parentheses, you're going to highlight these numbers here, comma, these numbers here. This is our p-value. So our p-value is 0.18. Okay, so our p-value is 0.18. So that is telling us that there is no difference because our p-value is more than alpha. So there is no relationship, no association. Okay? So here's a simple statement of how you could write up the results. No association was found between training and manager's function. P is greater than 0.05. We're going to keep it that simple.